Today we are discuss basic concepts of vehicle dynamics. I am Kamal Tiwari, Assistant Professor Automobile Engineering, Oriental Institute of Science and Technology. So the basic concept of vehicle dynamics is first we discuss the definition of vehicle dynamics. So the definition of vehicle dynamics is the mechanics of vehicles uh, static or dynamic condition. The mechanics of vehicles static or dynamic conditions, and the other way the dynamics consider physical calculations, analysis, models, virtual methods, practical methods to predict the vehicle performance, stability and concepts. Okay, so the basic contents of vehicle dynamics is how force influence vehicle motion and vice versa. So, motion like vehicle motions or force like side thrust, cornering force, aerodynamic force, impact force, or many uneven forces are reacted on the vehicle in any way: side force, side thrust, longitudinal force, vertical force, other forces. Second one is what is the vehicle response will be in certain driving situation. So vehicle act as a lumped mass. We can create a free body diagram. Every force disturb the vehicle. It can vehicle can react mechanically. Okay. Then how design will affect vehicle behavior. So design is the main subject of engineering, and many design challenge to design a vehicle. A vehicle can design different types of component will be designed uh, other way. So to ensure that the vehicle will absorb all types of forces, mass forces, weight, impact forces and others, uh, this is the perfect design of the vehicle. Okay, so what is the approach and assumptions to what is the approach and assumptions in vehicle dynamics? um, uh, Many assumptions are there, many degree of freedom. The system is many degree of freedom, multi degree of freedom. There are 6 axis coordinate system: x, y, z, minus x, minus y, minus z. It is very critical to assume their axis vector for perfect modeling. Second one is many inputs and outputs. There are many inputs and outputs. For example, road surface to tire. Inputs is road surface, tire. Tire is also the inputs. Suspension, output in the passengers. Vehicle to driver, driver to engine, engine to vehicle, acceleration. There are many types of loop uh, is there. So we can approach to input to output and output to input also. In modeling, there are many complex relationships in the calculations of the vehicle. For example, wheel dynamics is the branch, aerodynamics the branch, suspension analysis is the also and other branch, and ride comfort analysis, vibration analysis, roll center analysis. Many complex analysis are there for uh, calculating the vehicle performance, vehicle dynamics performance, or complex relationship is there. There are no any analytical study and experimental approach, but uh, in Indian conditions, in an Indian scenario, no facility available for student practically analyze the vehicle. Worldwide, there are no books available for practically uh, manuals for vehicle dynamics. So we can uh, we can create some modeling or virtual analysis to vehicle approach. There in India there are uh, many laboratories are there like Suzuki analyze the vehicle dynamics. Data Motors is also it can use chassis dynamometer, steering dynamometer, and other apparatus for vehicle dynamics approach. Last one is modeling and simulation. CAE modeling is tends to CAD, computer aided engineering modeling, and simulation. There are two other words. Computer aided modeling is the modeling, and simulation is the simulate two different models to each other. So we can use virtual CAE modeling for next future vehicles for calculations. There are three types. There are many types of forces, but we consider longitudinal forces or longitudinal vehicle dynamics. So there is one forces and motion longitudinal direction, smooth road surface. So there are many forces in this diagram. W is the downward weight, and this is gradient. Theta is the angle of the gradient. FD is the hitch point force it, uh, for attach any other trolley and other somethings. And H is the CG height. HA is the aerodynamic force height. FA is the aerodynamic force. FTF is the traction force from front wheel. FTR is the traction force for rear wheel. FRF rolling resistance force for front wheel. FRR rolling resistance for rear wheels. L1 and L2 is the distance of front axle and rear axle from midpoint, a CG point. Okay. NF is the opposite direction of front wheel weight. NR is the opposite direction of rear wheel weight. So this is the longitudinal vehicle dynamics conditions. This diagram shows the lateral vehicle dynamics. So many force are motions mainly in we can consider force and motion mainly in lateral direction. Predicting cornering performance, handling, and stability in lateral direction. So predicting cornering performance will taking turn. What is the vehicle speed is not to roll. Handling stability is tends to steering failure. Understeer or oversteer the vehicle is also considered in lateral dynamics. Then vertical vehicle dynamics. It consider force acting on the vehicle vertical direction.